Significant professional insights are rarely the product of a comfortable afternoon. They are usually forged under immense pressure. In the late 2000s, the economic landscape was effectively disintegrating. With unemployment spiking and major industries facing bankruptcy, the stakes of professional failure became visceral. When you are the sole provider for a family and the market is contracting, you cannot rely on established methods. Survival requires you to abandon the old roles and rapidly prototype new, efficient workflows out of sheer necessity. While that urgency is a powerful catalyst for innovation, there is a technical bottleneck. The biological mechanism we use to process these insights is fundamentally ill-suited for long-term storage. At the moment a complex technical insight ignites, that brief grasp of how to resolve a systemic bottleneck, it is vivid and actionable. But the human brain is a poor environment for data retention. Without an immediate capture mechanism, the details of that insight begin to decay within seconds. This creates a cycle of wasted effort. The lessons learned during a crisis evaporate, forcing you to solve the exact same problems from scratch when the next project begins. To break this cycle, insights must be aggressively memorialized. They have to be converted into tangible knowledge products the moment they occur. An unrecorded thought lacks utility. To survive the limitations of human memory, an idea must be mechanically trapped in a medium outside the mind. Once an idea is captured, it moves into a digital sandbox. This is a private environment where raw thoughts can be pressure tested and refined. Most professionals attempt this by typing their thoughts into static Word documents or PDF files. This approach relies on an antiquated storage logic. It fuses the actual meaning of the information with its visual formatting on a digital page. The flaw here is technical debt. When the visual standards of the software inevitably change, the underlying data remains trapped in an obsolete layout, making it difficult to extract or reuse. Treating ideas as unstructured files doesn't preserve them for future use. It effectively places them in a digital archive where they become increasingly difficult to access. The modern alternative is the paperless keepsake, a record built entirely on structured, machine-readable data. Structured data separates content from presentation. The fonts and margins are stripped away, leaving only the core data points and the relationships between them. By storing information as raw schemas and metadata, an insight becomes a modular building block rather than a finished, unchangeable file. In this machine-readable state, the data is highly portable. It can be instantly integrated into new software tools or shared across platforms without manual retyping. By removing the layout constraints, the original insight remains technically accessible long after the software used to create it has been replaced. Because these keepsakes exist as structured data, they can be indexed by central databases and served through APIs. This allows a personal archive to graduate into a scalable enterprise platform. This creates an idea museum. It follows the precedent set by Thomas Edison, who viewed his thousands of unsuccessful light bulb filaments not as failures, but as a recorded ledger of what didn't work. This illustration shows how that history is preserved. While the public only sees the final framed visual, the platform maintains the entire string of thinking work and previous iterations that led to that result. Storing these iterations as structured data enables a unique technical capability: retroactive improvement. When a new industry standard or AI model is introduced, a single rule change sweeps across the archive. The system automatically re-renders every past insight into the new format, bringing older assets up to current standards without manual editing. By converting fragile insights into a machine-readable pipeline, a body of work maintains its technical utility, even as software environments evolve. The initial effort compounds, ensuring that past lessons remain integrated with the tools of the future.